Hello and welcome from the MVTech headquarters here in Munich. It is autumn, it is November, it is time for a new release of HALCON. I hope you're all doing fine and that you're curious to hear about HALCON 22.11. But before we start, I want to introduce you the speakers of today. Your presenters are Mario Bohnacker, Technical Product Manager HALCON, Janssen, Technical Content Creator here at MVTech, and the third guy on the slide is me, Markus Setzer, and I'm happy to do this moderation of today's webinar. Some last information before we start. We have a Q&A session directly after the presentations. So if you have any questions, feel free to write them in the chat, in the GoToWebinar chat, and we are going to answer them live later. Also, you will receive a follow-up mailing after the webinar. In the next few days, you will get the recording as well as the new feature slides. All right, that's it for now. We see each other later for the Q&A session. And now let's jump right into HALCON 22.11 together with Mario and Jan.
Hello and welcome to the HALCON 22.11 Progress webinar. We have a lot of new features to present to you today, which are included in the new HALCON 2011 Progress version, which is was released just yesterday. The topics which are included in the new HALCON 22.11 release is, first of all, we have a new data type, which is called memory block. We have the protection of HALCON data formats, which is included in 22.11. We have added a floating license server for SDKs, a 3D gripping point detection algorithm for robot picking applications. We added guided Grad-CAM heat map for deep learning to have a more closer look into the black box of deep learning. And of course, as always, we added a lot of different speedups. Before we now dig deeper into each of these topics, we have one announcement to make at the beginning, which will make some of you not too happy. As we already announced in HALCON 22.05, we will not continue with HALCON for macOS. So this version, the HALCON 22.11 Steady and Progress version, are the last versions which support macOS systems. So at this point, we recommend to switch to Windows or Linux systems if you want to use HALCON further versions in the future. So now let's start with the new data type, which is called memory block. HALCON now includes this new control data type, which is memory block. And this offers a container for arbitrary byte fields and can handle memory ownerships. And the main advantage here is that you can use it to quickly exchange data with other applications directly through the memory, and can therefore, for example, transfer image data to non-HALCON applications via OPC UA. The details how this works and how you can use memory blocks will be introduced by my colleague Jan.
Thank you, Mario. A comparison coming from our development team that helped me to grasp the concept of memory blocks is the comparison between memory blocks and the serialization of objects. It's quite similar, but in a serialized item, you find meta information to interpret this byte field. With a memory block, all this meta information is missing. So the interpretation of the data is on side of the user. HALCON supports memory blocks in several ways, already coming with 22.11. We have the creation of memory blocks from external pointers, which can be done without or with making a copy into the internal HALCON memory. Then we have the conversion between images and memory blocks. We have, of course, the writing and reading of memory blocks to and from file, and, of course, writing and reading memory blocks from I/O channels. this allows us several things. One use case is something we are very excited about, is the sending and receiving of PNGs and JPEG blobs via OPC-UA or MQTT. So how does that work? Well, yes, I want to make it a little bit bigger for me because I was not able to see it. Excuse us.
It's okay.
So the sending is quite simple. You establish a connection to your I/O device. You convert the H image that you already read into memory into a memory block. And then you write this memory block out to your I/O channel. And this is quite simply as this. And on the receiving end, it's just as simple. There you receive the memory block by reading out the I/O channel and then convert said memory block to an H image. Within this is also an advantage coming with memory blocks, which I will going to explain in further detail now. And that is the conversion between PNG and JPEG blobs to H images. The workflow as before of 22.11 would be to write the image blob to file and read it via Halcon with read image to gain an H image. This is really restrictive. Sometimes you don't have access to a hard drive to write your data on. Sometimes you don't even have the rights to write on that hard drive disk or not the space for it. So with memory blocks, the conversion between PNG and JPEG blobs can be done all within main memory. So let's take a detailed look into this. For this, we simply just need, well, for the conversion of H images to PNG and JPEG blobs, we just need image to memory block. And then to use that memory block in external applications, we just get an external pointer or a pointer that we can then use in external applications from that memory block with get memory block pointer. The other way around, to convert an image blob to an H image, is to create a memory block from an external pointer and then convert said memory block to an H image. It is to be said that the conversion of image blobs, is as of 22.11 only supported for PNG and JPEG blobs. And I give back to Mario with another exciting feature.
Thank you. Yes, the next feature on the list is the encryption of Halcon data. So with the encryption of Halcon data, we now allow to have a data encryption for more security for all Halcon data formats which can be serialized. This means all data formats which can be serialized can be encrypted by the use of a password. And this is especially then useful in one use case, which is deep learning. In deep learning, a lot of the IP which you have on your side is inside the model which you create. It's the images you use, the parameters you use. So you put a lot of invest into this deep learning model, and you want to make sure that only persons who you want to have access to it can read it, can use it. And this is one use case for this new feature, where you can use a password mechanism to make sure that only you are able to modify and see your deep learning model, and therefore to protect your investment and your IP. And again, also for this topic, the details will be told by Jan.
Okay, customers came to us with several requests. They wanted to protect their intellectual property, and they want to ensure that the data that they will receive from their partners is authentic. And for us, this boils down to the simple task of protecting Halcon data from the influence of third parties. So how does that look within Halcon? How does the workflow look? And Mario beautifully described it already. The most prominent use case for this application is, for us, the protection of deep learning data sets. So, how do you do that? First, for the encryption, you need a password. And we give you no guidelines on how you receive or set this password. You can have a clear text within your script. However, we don't recommend that. In this case, you get your password by an environmental variable. Then, after you received your password, you read in the data you want to encrypt. In this case, a deep learning model. Then you serialize the deep learning model. And again, encryption works for all serialized items. This includes every data type which Halcon is able to handle. So, serialize your DL model, encrypt your DL model with the received password, and then write your encrypted item to file, so you can send it to your partner. At destination, your partner simply has to read the encrypted item, deserialize it, and yeah, the DL model is ready to use. It is to be said, to be able to infer this model, it has to be decrypted. And I give back to Mario.
Thank you. The next topic we included in the release is a new license mechanism, which is a license server. And the idea behind this server is to have a more flexible way to use Halcon SDKs. In principle, we have a new floating licenses where you basically install this license server on a server on your side, which then can be used and reached by different PCs in the network, extending the license possibilities, so you're not restricted to a dongle anymore, and therefore increases the flexibility in working with Halcon. So what do you need to set up such kind of license server? You need a server on your side on which you put in one USB dongle which is needed to run the server, and then via internet connection or via network connection you are able to connect a specific number of Halcon SDKs to these servers to get a floating license. There are various use cases for these license servers which we want to introduce at this point to you, and yeah, just to show you in which use cases it makes sense to use this kind of licensing. First of all, a very common use case is for big development teams. So if you have big development teams where a lot of people are working with Halcon but mostly not at the same time, you can now use the floating license mechanism to have a more easier administration. You do not need to hand dongles around, and you may also need less SDKs as an amount of developers can share an SDK. So one use case is these huge or bigger development teams which are working with Halcon SDKs. The second use case came up in the last 2 years quite a lot, is working from home. Working from home with Halcon SDKs had a problem that your engineers needed to take the dongle with them to their place, and then were not able to share dongles easily, and this was kind of a very strong restriction, especially during the last 2 weeks, with a lot of companies sending people to work from home or work from mobile. So with the license server and the floating mechanism, you now can add more independence, as you can use this license service inside your company and put up a license server there, and your engineers can connect via the company network, via VPN for example, to the server and then get the license from the server. So you are very flexible at this point to have a higher flexibility for your staff to work with Halcon. The third use case we have is the use of virtualized environments. So for virtualized environments, the licensing here is not tied to a physical host ID anymore. And in virtualized environments, you don't have a physical host ID usually. So in this case, you can run a floating server with Halcon SDK licenses and then connect these virtualized environments to this server to get the license. So another use case for this license server. And last but not least, we have one use case some people do not think of that much, but it's the maintenance of production machines. So you imagine you have a production line with several systems on which there are Halcon running, using the HDev engine, for example. And from time to time, you want to open an HDevelop on a production machine to do some debugging or to do some maintenance, to adapt some small things. And up till now, your maintenance engineer would need a USB dongle, carry in with them, and then put it into the machines and also carry around the dongle. Now with the license server, you have the possibility to set up one license server or one PC in your production line as a license server and put there the floating license. And just in the cases you need this SDK license, you can just open it on every connected PC machine and use the license via the network to run HDevelop. So also one use case for this new license server where you do not need to require an SDK dongle, and you can run your machines with the RTL and then just use the SDK at the time as you really needed it. So these are the four main use cases we see for the license servers. If you please get in touch with us on our sales if you are interested in this kind of licensing technology.
I have one more question. You mentioned big development teams. Are there any restrictions about how many licenses can be held onto this license server?
No, there's not really a restriction. We sell these licenses or license capabilities in packages of 5 what we call slots per server, but you can add up this to whatever number you like. So there's no real restriction on the maximum number of licenses which can be bound to such kind of license server. Yeah, that's the information about the license server. The next topic we have is the 3D gripping point detection. 3D gripping point detection is a new deep learning based technology which is the first in the METech portfolio which combines deep learning and 3D. So it brings the deep learning which is all around to the 3D world, and has one major use case, and this is to do catless bin picking applications. So the 3D gripping point detection can be used, for example, for bin picking with random objects which are suitable for vacuum grippers. This is one restriction where my colleague will get into a little bit more detail later, and allows the picking of a high number of different object shapes. And the big advantage for this, as you might think, okay, I can also do this with 3D surface-based matching, for example, is that you do not need any prior knowledge of the object shapes. So there's no training, it's just input 3D data and get positions where the algorithm sees possibilities to grip objects. But the one major use case is, for example, in warehousing, where you have a workflow where on a lot of positions robots need to pick objects out of bins or of boxes for commissionings. On other positions, objects need to be picked and made ready for commissioning. And so this was one major use case on which we developed this kind of technology. And as you can see here in this image, there's often bins where there is the same part available, but in a lot of cases there are many different classes of objects in one bin, which is kind of challenging as the object shapes can be very different. So what kind of objects are suitable for Halcon 3D gripping point detection? So here we see a short overview. You can use it for deformable objects like on the upper left. The same goes but also for non-deformable objects, like here in this example milk bags or packaging for the pharma industry. We have rectangular shape objects but also non-rectangular shape objects like the on the lower middle. Like I said before, same class of object, different class of objects, and the objects can be static, like in the image above, where you have a bin which is located at a certain position, or you have moving objects where you can also use this kind of technologies. We presented this feature already at the Vision show in Stuttgart as a demo, and for everyone who did not see this demo or was not able to join the Vision, we prepared a small video which shows you how this feature works live in action. So basically here you see our robot which is picking up different objects which were not trained before from one location, from one bin, and transporting it to another bin. Yeah, and the details, how this works and how you can use it with Halcon, is something which now Jan will tell you.
Thank you, Mario. Mario already explained that the 3D gripping point detection is a deep learning application. So a deep learning application, there is a deep learning model, which we pre-trained for you, so there's no need for training and teaching any further objects. But these deep learning models need certain inputs. So what inputs does the 3D gripping point detection need? Well, as inputs, you need a mapping of your 3D scene, an XYZ image and an intensity image. If you have it, you can also provide the model with a normals image. This is optional, but the normals will be calculated in the pre-processing of your data. And if you can provide the normals, pre-processing will accelerate quite a bit. For the outputs, we have a gripping map and the extracted 3D poses of the finally extracted gripping points. Let's take a closer look at the outputs. Coming up, the gripping map. The gripping map is basically a binary image. Everything colored in red is a possible gripping point. Everything colored in blue, the 3D gripping point detection was not successful in extracting a suitable gripping point. The final gripping point, which the model made its decision on, is here visualized by a green cross. The final gripping point is, of course, based on the extracted regions shown in the gripping map, and of course, how could it be else, the characteristics of the 3D point cloud. Then, of course, you have to be able to approach these gripping points. And to be able to approach gripping points, you need poses. The 3D gripping point detection will provide you these poses of the extracted gripping points. However, these are in respect of your camera coordinate system. So you have to translate them to your robot coordinate system to be able to approach them successfully. Mario already showed you quite a lot of examples, but I'm going to do the same because they are just so awesome. On the left, you always see the intensity image. In the middle, the gripping map, and on the right, the extracted poses of the gripping points. You can see here there are vastly different objects, and for all these objects, the 3D gripping point detection was successful in extracting a gripping point. And to drive my point home, I have much more examples like these. And one more. But what are the requirements to successfully use the 3D gripping point detection? First, 3D gripping point detection needs a vacuum gripper. Then, of course, you need a 3D point cloud that is high enough resolution for the 3D gripping point detection to conclude the properties of the surface of your objects that you want to grip. So a higher end or not a lower end 3D sensor. Then, of course, because it is a deep learning application, you have to provide your application with a deep learning appropriate computing device. This can be a GPU or at least an AI² accelerated CPU. And I told you before, the conventions of the input images is an XYZ image together with an intensity image. If you look at the workflow of the 3D gripping point detection, it does not differ that much from a normal deep learning application or the workflow from deep learning technologies already featured in the MVTech portfolio. You read in your deep learning model, in this case the pre-trained DL gripping point detection. You create your samples from your input images. Here, it's a different name for the procedure because this procedure, of course, works on 3D data, so you have to provide 3 channels. Apply DL model, it's simply the same. You apply the application of your model, and then with the results of the application of your model, you extract the 3D gripping points. So this is quite similar to the old or to the standard deep learning workflow. But Mario, does our customer who wants to use deep learning gripping point detection, does he need a deep learning license for that?
No, actually not. This new technology, the 3D gripping point detection, will be provided in the 3D module of HALCON. So a bundle license or a 3D license is enough to use this technology. So there's no need to buy the deep learning license for this kind of feature.
So, and because we don't expect you to remember all this by hearing it one time in the webinar, we will also provide you with a standard example featuring the workflow for 3D gripping point detection, which you can then use to jumpstart your applications. And of course, a great feature, there's always the question, how fast is it? We have done some benchmarks, and the point that we want to drive across with our benchmarks that we showcase here is the total processing time is always a little bit dependent on your CPU, because pre-processing and post-processing will always run on your CPU. But the applied DL model will take up huge amounts of time of your total processing time unless you provide the 3D gripping point detection with a suitable computing device. And I want to highlight one thing. An accelerated CPU outperforms a lower end GPU, like the NVIDIA GTX 1080. But an accelerated 1080 way outperforms even an accelerated CPU. This is even more true for a higher end CPU. So for the next feature, I give back to Mario.
Thank you. So the next feature is the guided Grad-CAM heat map, which is a deep learning feature, and you might have heard the name heat map in a few of our webinars, as this is now the 3rd kind of heat map we provide. You might remember the first heat map we had in HALCON 18.11, I guess, some time ago. Was quite slow in computation. Then we provided the Grad-CAM heat map, which was much more fast in computation and more accurate. And now we will provide a guided Grad-CAM heat map, which is also quite known in the research community. So this is not specifically invented from MVTech. This is just something we integrated in HALCON, which is also used by other research. What is the difference from this heat map kind to the existing one in HALCON? Basically, it's a more accurate visualization of the important areas of the image for the classification. As you might remember, heat map shows which area in the image were important for a deep learning classification to decide for a specific class, and therefore can be used to evaluate any kind of misclassifications or problems, figure out things you might need to adapt with your data set. So it can help to make deep learning a little bit more explainable and understandable to use guided Grad-CAM. And also here the details now shown by Jan.
Thank you, Mario. So, to explain it a little bit further, we have here a classifier that we've shown in many fairs already, in many trainings, if you had attended one of our trainings. This classifier is trained to distinguish between the hand signs of 0 to 5. On the left you see our input image, which is quite clearly a 3. And our classifier is successfully predicting it as a 3. In the middle we see the Grad-CAM heat map, which shows which parts of the image were most responsible for the decision of our network. These parts are, however, region-based and not pixel-precise. As you can see, there is some background highlighted here in the red parts, so the most falling into weight for the decision of the network. So to have a pixel-precise feedback about which pixels were most influential in the decision of our network, we introduced the guided Grad-CAM. And here you can see pretty nicely that the thumb was very heavily considered in the decision of our network, and the gap between those two fingers. If you want to try it out and use it for your classifications as a visualization, you can generate the heat map with GenDL model heat map. You just simply set the heat map method to guided Grad-CAM. For visualization, you can also set the parameter def guided Grad-CAM. Right. We have also adapted our standard examples, our pill classification, which you see on the bottom right corner of the slide. And I give back to Mario with an introduction to speedups.
Thank you. Before I go to speedups, I just wanted to add one thing, because just a lot of customers are always asking this, and we know that customers are using it. The heat map, in a lot of cases, customers use this to do deep learning segmentation. So they use the heat map result to actually do a defect segmentation. This, we need to tell, is not recommended, because there are a lot of examples where it doesn't work, but we see also a lot of applications where it works. So if you want to use this as an kind of quick deep learning segmentation method, go for it. But yeah, here just a disclaimer: we do not recommend, because it's just for highlighting and visualization. For real segmentation, we provide other deep learning technologies. Next topic is speedups. Usually this comes at the end. This time we put it in the middle of the presentations. As always, we have various technologies which are now faster. With HALCON 22.11, speed is always one critical element where we want to improve with each of the HALCON releases. This time, that's why it's here at the beginning, we introduced major speedups for major technologies which we just released recently. So you might remember the global context anomaly detection, which we released with HALCON 22.05. Now gained of a very large speedup. The exact numbers will follow by my colleague. And beside the speedups, we drastically removed the amount of memory which is needed by the model, making it possible to use it on less memory devices. And besides that, we also improved the speed for our QR code reading. So these are just two technologies I'd like to mention at this point, and the more details are coming now.
Thank you again. Well, Mario mentioned this. There are huge improvements to the global context anomaly detection model. In this benchmark, we showcase or these benchmarks are done on a 1080 Ti, so a quite lower end GPU. These models are comparable. One is trained with the older model of 22.05, one with the improved newer model 22.11. So when it comes to GPU memory consumption went down from 8.2 gigabytes to just 1.3. This massively reduces the hardware requirements, as Mario already mentioned. Also, training times here per batch went down from 401 milliseconds per batch to just 49 milliseconds. And of course, not only memory consumption improved and training times, this is also, of course, available with the new release of the DLT. You can there train and evaluate your own deep learning model for the global context anomaly detection. Of course, as I wanted to say earlier, inference times have improved as well. Here, again, the 1080 is shown on the top with the acceleration through TensorRT, and on the bottom we have an Intel Core i9. And both went down by a factor of 10, which is a huge improvement. And again, as it can't be said enough times, this is also available in the deep learning tool.
One question now, if I train my global context anomaly detection with the new HALCON 22.11 model, which obviously is much more faster than the one in 22.05, can I use it in the 22.05 in case I have a machine already running on this version?
Yes, you can. So a model trained with the 22.11 is inferable on HALCON 22.05. So there should be no problem if you have a machine running on 22.05 and you train a new model with the 22.11.
Thank you.
No problem. So this is all for the global context anomaly detection for now. And we jump to the QR code reader. The QR code reader is now faster on 64-bit systems and ARM-based systems. And the numbers are quite comparable. The standard recognition now takes about 70% of the time that it used to take. Maximum recognition is even faster and only takes about 60% of the time that it used to take. As said, these times are quite comparable to ARM-based systems, as there is also, for standard recognition, 70% of the previous time, and for maximum recognition, 60%. And there are also more operators that have got faster. We have the find data code. All find shape model operations are faster now. Amplifies gets faster. Erosion circle now faster. And last but not least, bandpass image is now only a fourth of the processing time that it used in 22.05. And now I give back to Mario, talking about speed.
There's another thing which can be used for speed up. Thank you. Jan just mentioned that also for the 3D gripping point detection, it's quite important to use suitable hardware on the global context anomaly detection speed up. We saw that suitable hardware can be a big factor for the factor of speed. And as you know, we provide the AI Square interface to be able to use plugins of deep learning accelerator hardware together with HALCON. There's a new one we want to introduce today, and this is the plugin for the Hilo hardware. Hilo is also a very strong and powerful deep learning accelerator hardware, and this gives you the possibility to have more hardware flexibility for your deep learning applications, so more hardware to choose from, and can be used for most of the ME-Tech deep learning technologies. This plugin can be used with HALCON 22.11. Important to say at this point is that this Hilo plugin is provided by Hilo. So if you want to test out Hilo hardware, just ask at Hilo when you get the hardware how to use it with Halcon. There's a plugin available at the moment for Linux, Windows version coming up. So yeah, very nice new addition to the AI Square plugins in Halcon. So now we went through most of the features I showed you at the beginning, but as always, there are much more smaller changes, smaller new things in Halcon which we want to mention also. And the first thing is that we now have a new mode for the PQI for data matrix ECC 200 codes. We already have PQI for data matrix ECC 200 codes in Halcon. And this is used quite a lot and a very robust method to do PQI, even if the setups of the camera setup is not compliant to the standard. So as we are a software provider, we follow at this point the standard at all the steps where we can as a software provider, but there's a lot of hardware restrictions or hardware stuff also to make sure which we don't have any influence. That's why now we have we are talking now about two different modes for PQI. One is the verification, which is based on a standard compliant setup as it is defined in the standard. So you can see on the left an image which is made with such kind of setup, where it's very clearly defined how the image needs to be acquired. So for this verification, you can use the new mode, which is decoding exactly along the setup, along the standard. Besides that, we have this process control, which does not need a standard compliant setup, which also follows the standard, but at some points we added some knowledge to make it more robust against deviation in the image, or like you can see here there is some perspective. So it's very important to say we have two modes. One, verification. You need to make sure that your setup is compliant to the standards. If you're not able to provide a standard compliant setup, you can use the process control way, which is more robust against such kind of deviations in the images. And how this looks in detail, again shown by Jan.
So to switch between the two modes, robust and reference, we introduce a new parameter, which is called Quality ISO IEC 15415 decode algorithm. Depending on what mode you want to use, you set it to either reference for verification or robust to process control. And Mario already mentioned, please only use reference if you can provide a hardware setup which is standard compliant to the corresponding standard. Okay, so what are situations where you want to use the robust mode over the reference mode? So this would be irregular lighting or insufficient resolution, or where you don't have a perpendicular setup, so there are perspective distortions of your data matrix. How do you set the parameter that I already mentioned? You simply call set data code 3D param. The name I already told you. You set it to either reference or robust. And again, reference is only suitable for standard compliant hardware setups. There are also improvements to generic shape matching. And the first thing is, everybody who knows generic shape matching or shape matching in general knows that the search operations take up time. How much time is relative. But the fact is, the search operation goes through many steps by just one operator call. You have the building of the image pyramids, search on the top level of the image pyramids, track down all your candidates to the lowest level, and then subpixel refinement. and our users had no way of knowing which step of those steps took up how much time. And this also translates to them not knowing the speed-up potential of the search operation, because time could be lost in the building of the image pyramids, which is not heavily influenced or not at all influenced by parameterization. And to combat that, we will now provide you with a time measurement, which will tell you which step took how much time. To get this time measurement, you simply set the model parameter time measurement to pipeline, and then after your search operation, you will automatically be provided with a time measurement within your result handle. Another feature which was currently missing from the generic shape matching operator interface is to retrieve a contour representing your created model. This is now available for the bottommost image pyramid. You do this by calling getGenericShapeModelObject and get yourself the contours. Then a usability upgrade is that you can now retrieve all your matching results as an dictionary. Well, some of you might say, why would I do that? All my results are in the result handle already. Well, this is simply because retrieving your information out of a dictionary is much more easier than doing it from a result handle, especially with the dot annotation introduced with 22.05. Then we leave generic shape matching and we move back to AI² accelerated deep learning applications. We received feedback from our customers and our distributors that the memory consumption and file size of our AI² accelerated models were a little bit too much or on the heavier side, which resulted in problems. So we thought about, yeah, we can fix that. And we ended up getting rid of everything not relevant for inference, resulting in a fraction of the representation, which is Halcon internal, which we could handle. So we hope you like it. Also deep learning related, we will now provide ResNet 18 as a pre-trained classifier. We were often asked about ResNet 18 and to provide it as a pre-trained classifier, and now it will join our compact network, enhanced network, ResNet 15, LXNet, and MobileNet V12 in our chain of pre-trained classifiers. If you're interested in using ResNet 18 or our pre-trained classifier, simply read in the model pre-trained DL classifier ResNet 18 and you're good to go. And for runtimes, we have done some benchmarks, and for runtimes, the ResNet 18 is comparable in our benchmarks at least to our enhanced network. Then we provide a new standard example for global context anomaly detection. This standard example only features the inference of a global context anomaly detection. This makes sense for us because with the release of the deep learning tool, where you can now train and evaluate your own model, you can use this standard example to just import your model trained by the deep learning tool and just build up from this standard application. This standard example features an application which we've shown on many fairs this year, a PCB inspection where we want to detect structural and logical anomalies. Structural anomalies in this case would be contaminations or scratches, and logical anomalies would be the missing of parts or the wrong placement of known components. Then coming up, improvements to HDevelop. To get everyone on the same page, this quick summary about the canvas. The canvas is a container for graphic windows, and you can organize them in this container, individualizing your visualization to your own liking. Right now, the behavior is that the canvas is really nice for visualization, but it hinders my development and debugging of my code because it's always in front of my HDevelop. We changed this behavior by enabling you to move the canvas in front of your HDevelop or behind your HDevelop. This is the first step to separate the development of your code from the visualization of your code. We have changed the default settings from a docked canvas in your HDevelop to a single graphics window, which is now docked on the left side of your HDevelop, because we think that is enough to debug your code. You can visualize whatever is now relevant for you in your process, and the canvas will now be used to visualize your running script. This is really important because, as it was before, debugging and development negatively impacted the visualization negatively impacted the development of your code. Because if you adapted your HDevelop for the visualization, it would be cumbersome to debug it, to debug your code. And also, if you optimized it for the debugging, the visualization would be lacking. So the default, as I said already, is now changed from a docked canvas to a docked graphics window. The floating canvas, however, is not yet activated as a default setting because it changes how HDevelop behaves quite a bit, and we want to receive feedback before we turn it into a standard configuration. And if you turn it on, if you want to turn it on, you can do so under Preferences. And if it's turned on, the first call of dev open window will open a canvas for you. Now let us look into a script where we run the option run program with floating canvas. Well, we first read in an image, then we get the size of this image. This is important later on because a canvas can of course be opened with a specific size. And for this we will use the image size. Then we segment relevant areas with a threshold, and then we want to open a window which opens the canvas, and we visualize our image. Another window is opened, which is also automatically placed into the canvas, where we want to also visualize our image, but also the segmented regions. If you press F2 and reset the execution of your script, this will now also close the canvas. The canvas is now more accessible. It can be, as said, in front or behind HDevelop. It is minimizable completely separately from HDevelop, and it can be selected via taskbar of Windows. One more improvement for HDevelop is an introduction to a pixel grid for zoomed images or zoomed graphics windows. On the left, you see a zoomed graphics window without a pixel grid. So it's quite confusing to see which gray value belongs to which row and column coordinate. And with the pixel grid, this gets much easier. And if you don't like blue, like in this example, you can configure the color under Preferences. This sets the persistent default for all graphics windows, but you are also able to configure the pixel grid separately for all graphics windows that you open. This is done quite simply per window. You can also do it with the operator call set window param pixel grid. ROIs have also improved, or at least the ROI window has been extended with a slider now controlling the ROI opacity. This is a global parameter. So this applies to all ROIs that you will configure in your program. The default setting is to 50% opacity now. And this is just so useful because under an ROI, there's relevant information and you want to see which areas have you segmented. But some of you might say, this isn't a new feature. Well, the slider is. Transparency for regions were actually introduced with HALCON 13, but were only accessible by using def-set-color. Then we come to another improvement, and now the handling of numeric limits is now consistent within HALCON. Before 22.11, passing an integer, a numeric literal as an 64, 32-bit integer, well, assigned integer will always be assigned integer. This is to say working operations have not changed, but passing a out-of-range integer resulted in undefined behavior. Oftentimes it was an overflow, but as said, it was undefined. And now in every case of a passing of an out-of-range integer, an error is raised. This is also applicable for float values. Also, tuple number has been changed accordingly. Now the passing of 64-bit unsigned integers will always result in signed integers. Out-of-range errors will be handled the same. Typecasting errors, however, will now be impossible. This is for float values. Behavior has not changed for tuple number. So to detect those errors sooner, we have also now implemented some things into HDevelop where, for example, writing an out-of-range integer into your program window will now result in an invalid line. And of course, as I told you before, tuple number typecasting errors are now impossible. You can see here it resulted in an overflow. Now, as it should be, an error is raised. To make this a little bit more easier, and because all those constants and numerical limits are pretty hard to remember, we have also now introduced them as HDevelop constants. We have done this for integer limits, where we have now the maximum integer value for a regarding system and the minimum integer value. This is, of course, for 64-bit and 32-bit. We've done this for floating, but this is not only for floating points. This is not only the numerical limits. This is also epsilon or other constants that you might want to use. This extends for 64-bit floating points even further, where we provide even infinity, negative infinity, and not a number. This is it for the numerical limits. We now jump through image acquisition. And we are excited to make it a little bit easier for everyone. For those of you who tried to configure a camera before, you possibly used our image acquisition assistant. And opening the assistant is really helpful, but under the parameters tab, if you don't know what you're looking for, it's oftentimes confusing and overwhelming. And we tried to, well, we said to ourselves, we can make this easier because most of the parameters are not used by most of the people. So let me introduce you to the easy parameters or easy params, which will now be found within the image acquisition assistant under a new tab, easy params. Here we have a small selection of parameters that we think are the most used when setting up your camera, and the most standardly used. The great part about them is shown here. The names that you can see here are the HALCON internal consumer, GentL consumer names. So the names will not change even if you change your acquisition setup. However, it is said that if a camera manufacturer is not naming their parameters up to standard, HALCON will not be able to find them and locate them for the easy params. And now we think that people who don't use the advanced parameters will now be much faster in the setup of their camera. An example how this makes setup of your camera easier is, for example, setting a trigger. And for setting a trigger, you need to call set frame grabber param 3 times. You have to select the right trigger, frame start, acquisition start, line start, exposure start, and many more. So this alone is confusing. You have to turn it on, and you have to define the right I/O channel where you receive this trigger signal. With easy params, this boils down to setting just one parameter, trigger, where you just define the I/O channel. This is, of course, heavily boiled down and simplified, and the easy params are not designed for people who want to address complicated image acquisition setups. This is for people who want a quick and easy setup of a simple camera. And those people, we hope, will love that feature. Easy params are grouped into 4 groups. We have exposure, gain, trigger, and general info about your camera. The exposure only contains 2 parameters, the auto mode and the manual mode. You can specify if your exposure has to be set automatically. You can do this once or continually, or if you want to turn it off, you are able to adapt your exposure time manually. This is the same concept for gain, exactly the same. For triggers, this is a little bit more complicated, but as I showed you before, trigger, you just simply tell HALCON which I/O device or I/O channel you receive your trigger signal where from. Trigger activation would be if you have a rectangular signal like rising edge, level high, falling edge, level low. So you specify when exactly this triggering will happen. Of course, you can also delay your trigger, and you can configure a software trigger. Then device info. And this is a special parameter group that you won't be able to find within the image acquisition assistant. But you can receive all those information by calling get frame grabber param. And with the easy parameters, this is the last feature we wanted to show you.
Thank you.
And I give back to Mario.
Thank you. So that basically is the end of our technical presentation. This concludes all the features we introduced into this new HALCON 22.11 Progress Edition. And now we will quickly prepare the Q&A session. Therefore, we will screen your questions. This will take us, let's say, 2, 3, 4 minutes. And meanwhile, via the chat, you will get a link to the Q&A, which you already know from previous webinars where we ask you about the value of our new releases. So please give us your feedback in this Q&A, in this, not Q&A, now I'm making a survey. Thank you. Please give us your feedback in this survey. And yeah, we will be back in 2 to 3 minutes and go on with the Q&A. See you.